Hi, my name is Stephen Brock, and this is my COVID-19 data analysis. The objective of this notebook is to investigate and analyze the spread of the coronavirus disease called COVID-19 over time. If you're curious to learn more about the disease, please click this link. The data is from the Johns Hopkins University's GitHub page, and the link is right here. It's from January 22nd, 2020, and it goes to April 3rd, 2020. It has data on 181 countries worldwide and contains information about country, location, number of cases, confirmed, recovered, or dead. This notebook is divided into four main sections: the summary, visualization, analysis, and prediction. So let's jump straight into the summary. For the summary, I use PySpark's data frame structure and use the describe function as well as the approx quantile to look at the data from a high-level point of view. In terms of the recovered cases, or in terms of the confirmed cases, on April 3rd, 2020, every country had at least one confirmed case of COVID-19. That's all of the 181 countries have at least one case. Just talks about how far it's spread on the globe. At least 75% of countries have at least 21 cases, and the standard deviation of these cases is actually increasing over time, which is just talking about how countries are reacting to COVID-19. I did a similar analysis for the recovered cases and the dead cases. What's interesting about the dead cases is that the 25th percentile becomes 1 on April 3rd, 2020, which indicates that 75% of the countries now have at least one death of COVID-19. It's deadly. In terms of the visualization, I created graphs using pandas and matplotlib and this graphing function that I created. So here is the confirmed cases. We can see that in the beginning it was just China that had infections, but then Spain and Italy took off, and the US really took off and got crushed by this disease. At the beginning of March, 75% of countries had 0 cases, but at the end of March, 75% of countries had more than 15 cases, which just shows how fast this virus spread in a 1-month period. The trend of the recovered cases looks very similar, and the trend of the dead cases also looks similar, except that Italy, Spain, and the US are still on the rise and could be overrun. Their medical system could be overrun by the COVID-19. I also created a scatter plot with an increasing radius, an interactive scatter plot. So we can see on day 0, China is the only country that has cases. But as we increase to day 12, for example, we can see that some of the cases are spreading to Japan, Spain, and Italy. And if we increase to day 37, we can really see the spread of COVID-19 on a global scale. The X and Y axis represent longitude and latitude respectively. In terms of the analysis, I want to look at more specific questions about the data. So if we scroll down, we can see that some questions I came up with are: what day did each country get their 1,000 plus cases? Which countries didn't even reach 1,000 cases? How did the total number of cases change? And how did the total number of cases per continent change? In order to answer these questions, I performed queries on the data and created user-defined functions. One of the user-defined functions operated to find the day where they reached 1,000 or more and the cases, and the other user-defined functions compared pairs of columns to figure out what the difference was for each day. In the results, we can see that of the countries that hit 1,000 cases, it took them about 50 to 60 days to get there, and 126 countries of the 181 countries didn't even reach 1,000 cases by April 3rd, 2020. The biggest day globally for increased case count was day 52 with over 16,000 cases, and this was on March 13th, 2020. Asia, North America, and Europe all got hit pretty bad by COVID-19, but South America, Africa, and Australia didn't get hit as hard. In terms of prediction, I wanted to create a time series linear model using PySpark's RDDs, and I trained it using batch gradient descent. The predictive features were latitude, longitude, previous day confirmed count, and time. Unfortunately, the model's average relative error was greater than 0.1, which shows that it actually wasn't very predictive, and the relationship between the explanatory and response is not linear. In terms of the evaluation of the notebook, most of the sections, or all the sections, gave like fruitful results. The summary, visualization, analysis, except for the prediction. But it still gave us information about the data. Thank you very much for listening to my presentation.